advancing construction sector, decarbonizing through alternate materials and demand optimization techniques at FEED 2023, organized by Alliance for an Energy Efficient Economy. In India, the increase in urbanization has led to a rampant rise in construction of buildings. According to AEEE's estimates, India's total building floor area will be around 30 billion meter square by 2030 from 15.8 billion meter square in 2015. This growth would also spur the demand for conventional construction materials like cement, steel, bricks, glass, etc., which are highly energy and emission intensive. This session would attempt to shed light on mitigating the embodied carbon from the construction sector through discussions covering all phases of building construction, from extraction of raw materials to the disposal and recycling of demolition waste. I would now like to introduce and invite our esteemed panel to the stage. Our first panelist for this session is Dr. Soman Mehti, Chief Technical Officer, TARA, and Vice President at Development Alternatives Group. Dr. Soman Mehti is leading the innovation to commercialization value chain under Technology and Action for Rural Advancement. His current sectors of interest are industrial waste utilization, resource efficiencies of small-scale technologies, low-carbon cement, alternate building materials and technologies. Welcome, sir. Next, we have Mr. Anish Jain, Manager, Zynteo. Mr. Anish has more than 12 years of experience in areas of decarbonization, sustainability, energy, power markets, and renewable energy as a consultant. He is currently leading the Building Ahead Coalition, an industry-first initiative to accelerate decarbonization of the construction value chain in India with a focus on embodied carbon in the built environment. Welcome, sir. Next, we have Mr. Prasad Vaidya, Director, Solar Decathlon India. Mr. Vaidya is a lead fellow with 25 plus years of experience in energy policy, program development, and net zero energy building projects in the US, Korea, and Middle East. He has led the development of Eco-Nirman whole building performance and energy simulation compliance tool. He has also co-authored Fundamentals of Integrated Design for Sustainable Buildings, published by John Wiley and Sons. It's a pleasure to have you, sir. Next, we have Mr. Gurneet Singh, Director, Environmental Design Solutions. Gurneet is a highly experienced sustainability and building performance diagnostics expert and educator. He has led the energy efficiency team at EDS for nearly 20 years and has successfully implemented over 200 projects. He has been a long-standing advocate of green buildings and net zero energy buildings, helping developers, organizations adopt different green building certification and energy efficiency codes. Welcome, sir. Last but not the least, I'd like to welcome our session chair, Architect Ashok Lal, Design and Technology Chair, Trivia, Mumbai. Architect Ashok Lal specializes in environmentally and socially sustainable design. He has researched and written on the subject of sustainability extensively. He has also been involved with architectural education since 1984. Before his current stint, he was the Dean of Studies at TVB School of Habitat Studies, New Delhi. It's a pleasure to have you, sir. I hand over the floor to you.
Well, thank you very much. This session is about decarbonizing the construction industry and buildings in two ways, through improving, three ways, through improving the production, the carbon intensity of production, through alternative materials that can replace high intensity, carbon intensive materials, and also by demand optimization in buildings themselves. So it's not only the embodied carbon that we should be talking about, we will also be referring, and I think Gurneet will elaborate on this a bit more, Prasad will too, on the operational carbon, because when you look at these two together, that you really get the full picture of what we are talking about. We've been told that we're going to double our building stock by 2050. A huge amount of construction is going to happen. Just imagine how much construction is now compressed in just 3 decades, all right? And imagine that you actually have only 10 years as the window of opportunity to halt the progress of carbon dioxide emissions significantly, to be able to reach your 1.5 degrees target of rise of temperatures. Okay? So you really got a 10-year opportunity within which you've got to work. And in India, most of what we are told will be the additional construction, 80% of it will be low operational energy type of building. Homes, schools, small offices, whatever, shops, commercial centers, etc. Low operational energy. The impetus or the bang of carbon dioxide emissions will happen in a very concentrated manner over these next 10 years. And that is why embodied carbon of construction becomes a significant aspect of fighting climate change mitigation. In rapidly growing economies, if you take China, Indonesia, India, Mexico, the same story will repeat itself. So this is where the shift is so important for us. In construction, we also find that the big culprits are steel, cement. Cement accounts for 5% globally of carbon emissions. Of the 38% that is attributable to the built environment, about 8% is directly attributable annually to embodied carbon. All right? This is looking at it globally. But if you look at it in India, it will be the other way around, because embodied carbon is going to take the cake. Right? So cement and steel is a big one. And then, of course, followed by glass, aluminum, all the so-called modern materials, including plastics. Brick is also another big issue that we are looking at. So anyway, this just gives you a background of the situation we are facing and how urgent it is for us to address it. I'm going to start by asking Mr. Mehti to talk about some research and development of alternative cement with low carbon intensity and other thoughts about alternative materials. Over to you. You want this?
Thank you, sir. Before I go into the work that we are doing in low carbon cements, just to give you an perspective of the cement industry in India. We are the second largest cement producer in the world. After, of course, China, we produce roughly approximately around 400 million tons. And by 2050, it is projected that we are going to grow up to more than 1,200 million tons. That's the kind of growth that we are looking at. But even compared to all the countries in the world, our carbon intensity in cement production is the lowest. We are at 0.65. The only reason is that 67% of our production is fly ash based cement. 10% is Portland slag cement, and the rest 23% is ordinary Portland cement. That's the main reason. But still, we contribute to around 7% of the country's emission, the cement sector. This amounts to, this year, last year it was a little bit low because due to COVID kind of situations. This year it is the total carbon emissions from the cement industry only will be roughly around 160 million tons. We say ourselves that we are the best cement industry, but we still emit 160 million tons. So considering that scenario, and we are looking at how to decarbonize the cement industry, there are two possibilities. One is through the geopolymer cements, and another is through what we call it that the limestone calcined clay cement, which is a combination of, it is basically we are reducing the clinker factor from around 0.72 to 0.5, and if it can also be further reduced to around 0.4 also, which means directly we can save up to around 40% of CO2 from the production of this also cement, and roughly to around, in certain cases it can go even up to 60%. But so that's the kind of work that we are doing over the last 8 years. It has been a quite an extensive and journey. It's in collaboration with IIT Delhi, IIT Madras, EPFL in Switzerland, and other some of the cement companies. The recent developments are that the standards, the most important thing, if you have to produce or use cement, is you have to have the standards. The standards, we have been working with BIS, and happy to share that the standards has been approved now by the technical committee. They are in the printing. So probably in another 2 to 3 months, the standards for LC3 will be out. We are working with almost all the cement companies, with the likes of Ultratech Cements, JK Lakshmi, JK Cements, India Cements, and Dalmia and all. So everybody, we are working with them in gearing them up for once the standards are there so that they can introduce the product into the market. It is about looking at the clays, where are the clays, where are the doing pilot production, and even going up to production scale trials also. Since we had been working over the last 8 years, so now we have data on extended durability tests. We had done short-term durability tests, and those gave excellent results. So we now have over 8 years of extensive durability testing with IIT Madras, which gave excellent results. This cement is even better in harsh environment near the coastal areas, or in desert areas, or in the where you have permanent snow in the Ladakh, Leh and Ladakh region. We had built a small helipad in association with the army, and over the last 3 years, there has not been a single crack. 6 months it remains under snow, and 6 months it is exposed. So there has been not a single crack. Demonstration, we had done some large demonstrations. One is in the sea with L&T construction, building tetrapods, and a place called Kodamkulam near the sea, near Kanyakumari, to test how it behaves in saline environment. And happy to say that they have asked for 20,000 tons of more of cement to do it across, replace all the tetrapods by LC3 based. Yeah, please.
I think it's now a fantastic thing that we do. We look forward to having alternative cement, which is now proven as a reliable replacement to conventional cement. So from Portland cement to fly ash-based cement to now the calcine cement, it's a real progress. Just 2 questions. One is, you've done this work here in India. What about the international take-up on it? Right? Second, what do you think needs to be done by policy to ramp up the rate at which this becomes an adopted production line?
First, answering to a question on the international area, they have even progressed faster than India. 3 countries have actually started commercial production of LC3: Colombia, Ivory Coast, and Ghana. Ghana, a cement company, has invested roughly a couple of $1 billion in setting up a huge calcination facility to produce LC3. There are but the most high demand is coming from the South Asian countries and in African countries. In South Asia, there are countries like Bangladesh, Nepal, Sri Lanka, and Thailand. They import, the cost of clinker is high. In Bangladesh, they import clinker. Nepal, they produce clinker, but they also import fly ash from India. So the cost of production is very, very high. Even Sri Lanka imports clinker. So all these countries are looking at LC3 because clay is available within the country, and they can reduce their production costs also. Similarly, in Africa, give you just one idea, is that the cost of production of clinker in India or in Europe, in other countries, roughly it is around $30 per ton. In Africa, it is between $80 to $90 per ton. It is more than 3 times. And clay is available in massive, massive quantities. And that's one of the primary ingredients of making LC3. In Egypt, we had find out a clay deposit which is roughly around 300 square kilometers. Depth, it is unknown. We couldn't go more than 20 meters. So it is much more applicable in, and the continents of countries like in Africa and in the Middle East is coming up in a very, very big way in adopting this. Only from the reason of cost, and but because, yeah, the cement company says that we have to do a business. And if with an added bonus, if there is an reduction in carbon emissions, then they say that it's added bonus for us. In terms of policy, basically in India, what we are now looking at is, well, that age-old question of bridging the demand and the supply gap. Cement, there are institutions, there are construction companies who are saying that we need it. The Noida Airports Authority wanted to use LC3, 50,000 tons, but there were no cement companies who were willing to produce it, because they said that we don't have the standards, how can we produce a cell? There are companies that are willing, that are on the verge of production for India purposes. I might not be able to share the names of the companies and the plants, but there are at least 10 plants that are ready with commercial production. And they are also finalizing the marketing plan, the bagging, and other issues also. But demand and supply, what I think one of the things that we are also looking at working with the government is using this LC3 in a large-scale demonstration projects.
Okay, well, thank you so much, Anup, for giving us this very hopeful perspective on reducing high embodied energy cement demand and replacing it with the new cement. Let's go now to Anish, who is working with a number of companies, working with them so that they reduce their carbon footprint in their supply chains. And so this, in a sense, he represents the demand side, okay? And how is the demand side shaping up to actually move in the right direction? So I'll just hand it over to Anish to share his thoughts.
Sure, thank you, sir. So coming in from a demand side, sir, like you said, and from a construction industry perspective, we've been speaking to a lot of different major construction companies, both across the real estate and the infrastructure space, and really trying to understand what are the challenges that they would be facing when it comes to embodied carbon in particular. There is a wide sort of spectrum of the understanding that we've seen across these companies, starting right from a very basic lack of awareness around what embodied carbon would mean, how does it impact in terms of the whole building life cycle carbon assessment. The current focus has largely been on operational carbon. All the interventions that have come up are to do with energy efficiency or operational carbon. Then there are some progressive companies sort of starting to think about, okay, if we have to look at embodied carbon, how can we actually measure it? What are the tools available to measure it? What are the methods? What data do we need to actually get a sense of what's the baseline emissions or the baseline footprint of embodied carbon that we are dealing with? The next stage comes when they get an understanding, or they sort of get some reference baseline. Then how do we actually address reduction of embodied carbon? And there, a lot of the challenge has to do with that once the building is built, there's very little that you can do with reduction of embodied carbon. So it's more of a future forward-looking sort of scenario where they have to think about strategies on what can they do for embodied carbon on the new projects that are coming up, on the new construction that has to come up in India, of which there is a large volume supposed to be coming up. And then finally, what is the actual roadmap that they should look at? What are the methods in terms of alternate materials? Are there cement producers, like Sir mentioned, who are now producing low carbon cement? Are there steel producers who could be coming up with low carbon steel or green steel? And then are there any other methods in terms of the design of the building where they can reduce the materials used or optimize the materials used so that the embodied carbon becomes lower. So broadly, we've seen these challenges across different companies, and that's where the industry is today.
Well, I mean, it seems that people are recognizing the need to do so, and that they are ready to go ahead. And you sort of laid out the different factors that need to be looked at. Do you think there's anything in by way of incentives or policy or standards of, let's say, embodied energy intensity per square meter of built space that need to be put out so that people, are encouraged to meet, to meet new targets or set targets? Is there something like that still not known? Are there no standards about it? Are there no incentives on reducing embodied energy?
Absolutely, sir. You're right. So, like policy, when we think about policy, the first few things that come up are there should be incentives for doing something better for the environment, or the policy should mandate that once the policy comes in, everyone will sort of start following in. But there are also a few more sort of enabling policies which we've been thinking about. A few of them, like you mentioned, about standards. And if we extend the standards to even the green ratings, so even when we call a building green, when a green rating is given from a USGBC or a LEED or a IGBC, there's very little focus on the embodied carbon, on the materials used. Even if you are not doing anything about the materials, you can still get the highest rating, the platinum rating, and you might be using the dirtiest cement or the dirtiest steel out there. So that really needs to change the weightage of how the green building ratings are given. That needs to sort of enhance to get some focus on embodied carbon. The second area where we're trying to see is to create a demand for low carbon materials, and that is where the government, as a large procurer or an influencer of procurement for infrastructure projects, they can come up with procurement policies that all infrastructure projects have to use 20% of low carbon cement. That itself puts in a large demand signal in the market that yes, there is so much of demand. So all the production companies need to get in line that yes, there are companies the government and then the companies who will be demanding materials. So we need to produce lower and lower carbon materials.
Well, I think we were discussing these issues earlier, and Prasad said, look, when it comes to looking at embodied carbon, there are 3 levels at which you can really attack the issue. He said, first, you must be careful about how much you need to build. Look at the programs. Do you really need to build so much? Can you reduce the sizes of what you need to build? That's the first level. The second level is the systems that are through which the buildings are built. You can design systems which are less steel intensive, less cement intensive, and so on. So you can design systems which are less embodied energy intensive, right? And then finally, what was the third one? You look at the substitution of materials, whether it is walling materials or flooring materials or ceiling, whatever else you may have, substitution materials. So these are the 3 levels. And so I'm now going to ask Prasad, who's been really working and watching young minds, our students in engineering and architecture, wrestle with the issue of net zero carbon. Tell us the story.
Thanks, Ashok. Okay, so let me begin by saying that on January 9th of 2020, we're in 2023? Yeah, 2023, the Council of Architecture came up with an interim report on how to align architectural education with the new education policy. And it laid out different priorities for subject areas and competencies, etc. So, as one might expect from past experiences, although one might not expect it from the story that Ashok has been telling about what we are facing in the next few decades, there was nothing mentioned, no priorities on decarbonization, no priorities on approaching net zero, learning about climate change, and addressing climate change. So the reality is that in architectural education, this is simply not addressed. It's not there in the curriculum, it's not there in the coursework, and you find very few faculty members who have the capacity to be able to deliver this kind of education. Now, this is the reality of the architectural education. In civil engineering, interestingly enough, you do find coursework that addresses building materials and their embodied energy. Not always, but it's there. Yet you don't find civil engineers who take this into a problem-solving approach and connecting it with decarbonization, connecting it with the climate change issue. So while they seem to have the knowledge and maybe some of the skill sets, they haven't been introduced to the problem itself. So where do we go from here? We've got, you said 2 decades or 10 years where we need to make a big difference. And we've got a national education policy aligned architectural education that if it misses the boat, we'll end up with a whole slew of people who will come out with no skill sets to address this, no ability to deal with climate change. And the next 10, 20 years, we'll build buildings that are locking in carbon or emitting carbon, and they're going to be around for the next 70 years. So basically, we've taken this century and we're done with it, right? So the flip side of this is that there is a small little sliver of hope that has emerged. And this is what I'm doing with Solar Decathlon India. This is where in the last 3 years, where we've introduced this as a design challenge, where students from colleges work with real estate developers and building owners. They come in and work on these real projects to make them net zero energy. And for 2 years, we've had students who were learning and proposing net zero energy solutions and learning the stuff. This is more important than actually doing the projects. They were learning the stuff because that's going to affect their careers. And this year, we introduced embodied carbon as one more contest that the students have to take up. So now, this year we've got 1,800 students, 116 colleges, and about 165 faculty members who are working on this, who are learning and doing this going forward. So if we can scale up this kind of education, if we can, maybe Solar Decathlon India, maybe some other way of making sure that this goes into curriculum, then the next generation of building professionals will be enabled to deal with decarbonization. Otherwise, we have to learn it in the profession, and that's hard. That's just hard, because you're working on a project and you don't have the leeway to be able to learn.
Well, you're not done. I think you also, I would like you to reflect on the work that students have been doing in the cycles of the decathlon that you've had, and to emphasize the role of design in, as you just mentioned, the role of design in actually reducing embodied carbon as you build. So this is a skill, or this is an ability which only, I think, architects and engineers, when they work together, can develop collectively, all right? And at the end of the day, everything comes together in the configuration of the built solution, of the building solution. We miss this aspect. We talk about business opportunities, we talk about reducing the intensity of production, carbon intensity of production, we talk about replacement of materials, but we never talk about design. So would you like to say something more about that?
Okay. All right, so I guess I'll start here by saying if we just look around here, there's probably 1 or 2 materials in this building or in this space that are carbon negative, which is basically wood and maybe some fabric around us that might be from cotton. Everything else is carbon positive. And these are choices that have been made by designers. These are choices that could have been made differently. And the role of design is being able to understand the impact of the decisions that you make. The role of design is able to understand and broaden the impacts that you look at. So when we've seen the work that the students have done over these 3 years of the decathlon, you can see that they're no longer simply dealing with building or designing a building. They're no longer just saying that, oh, I got to put 5 floors, this much FSI, and it has to look good and it has to stand. They're actually looking at the impacts of what happens with their design decisions. So it is now evidence-based design, and they've been given 10 different goals. One of those goals is net zero energy. One of those goals is net zero water. Another goal is to make a building that's affordable. Another goal is a building that has architecture that integrates engineering. And these students have to do this as a multidisciplinary work. So they have to work with each other as architects and engineers, and they're developing the skills now to be able to communicate with each other. So we've seen cases where students are coming up now with the ability to integrate these systems and produce evidence that says my building is going to produce so much energy, is going to consume so much energy, and they're doing those with simulations. This year they'll be doing the same thing with their embodied carbon decisions. And being able to make these decisions and anticipate them in design is extremely important. So, Ashok and I 20 years after you probably started in the architecture field. But when we started work, and you'll see this, that architects often become good architects around the age of 40. Before that, they're bad architects because they're making mistakes. So they finish their architectural education at the age of 20, 25, and for 15 to 20 years, they spend their and their clients' money and materials making mistakes. And at the age of 40, they learn, because it's an intuitive process where you learn from your buildings. You learn from the performance of your buildings. But now, because we have quantification and estimation tools, maybe we can learn that in 2 years. Maybe we can learn that in 1 year. And that's what these students are learning to do. How to not make mistakes for 15 years before you become a good architect.
Thank you. I think we need to start another school of architecture and engineering where this is taken very seriously, even before the Council of Architecture wakes up. So, coming to you, Gurneet, you did bring out the issue of looking at carbon emissions holistically in building, and you have been talking about, as we were having earlier discussions, about working with designers and developers in evaluating the carbon emissions of their designs as the designs are in progress for them. And so you tell us about your experience and tell us about what might be the bottlenecks or the challenges that you still face.
Yeah, so we have been working with, developers, corporates on, energy optimization, design optimization. Now with this commitment that is coming from each of this organization of going with carbon neutrality, they are now also very, I would say, open about looking into the embodied carbon factor also. Because the scope 1, scope 2 is more on operation, scope 3 talks about more on the embodied carbon. So I would say now the organization, builders, corporate, they have started looking into this factor. They still have to go to that stage where they are open to try or experiment different low carbon materials in their design. But at present, they are trying to at least assess, as we said, that there are no standards. So if I ask somebody have to tell what is the standard or benchmark of embodied carbon for a building. Is it 500 kilogram per square meter? Is it 600? It is 1,000 or 12? So there is no standard, there is no benchmarking on this number right now. So many of these corporates are now trying to establish their internal benchmark from their previous project so that they can actually have a benchmark and then try to improve on that benchmark. So, and they have started looking into getting that information. So even if they have to calculate the embodied carbon for their previous project, they don't have any information that how much embodied carbon of that cement is there. So they take certain assumption. But since they have started asking, what I have observed is I can see a shift in the market awareness. Now manufacturers are also open in declaring their embodied carbon, right? They have started declaring their embodied carbon. Now there are major like 20 to 30 manufacturers or type of materials for which the EPDs are available. So that information is available, and now when they are making that information available, they are also conscious on that their material, their embodied carbon will be compared with a competitor. So they are now started also looking into optimizing or reducing their embodied carbon factor. So I would say at this stage, the building industry have started that the change in that. It will still take 5 to 10 years to come at that level where they are looking into alternative technologies. Like we are talking about reducing the cement content or through different materials. But if we talk about design, there are research going on where they are reducing the content of cement by 70% by going with the vaulted floors, right? Those technologies are there. They are looking into alternative materials to reduce the cement thing. And those are all technologies which these developers will take some time to implement in their project. And what is required, another interesting observation is, a building for a developer is a product. It is something similar. A mobile phone is a product for a manufacturer, or this glass is a product for a manufacturer. If you see all these manufacturers, they have a R&D department in their facility, where the purpose of R&D department is to look into new materials, to optimize the design, to optimize the content and everything. And if we see this as an industry, building industry, where building is a product of a developer or we designers, I feel that research and development department or team is something missing. That's why the rate of acceptance of new technology is very, very low, very slow, right? So like there is somebody did a research and they come up that, okay, it saves time. And now if you see, every developer is actually looking into that. And with all the beam structure, you can easily replace your block work with mud block works. But not many developers are even open of exploring that or getting into that. It will not impact their structure and everything. But this slight change, even replacing the stone with a agrofiber kind of boards, false ceiling with agrofiber kind of boards, the technologies are there, they are available. But I would say the developer or this community or even in architects, structure engineer, they need to have, or the associations related to designers, to structural, to contractors, should have a research and development division or team who actually explores these things, implement in pilot projects so that it can be scaled, can be adopted by them.
Just a couple of thoughts. What the scenario that you seem to paint for us is that it's going to take a long time for habits to change, for standards to develop, and confidence to be infused in different players in the building construction or building design chain to actually switch over to low embodied carbon design and construction. It's going to take time. That's what you're saying.
But it has started.
It has started. So that's a positive thing.
Yes, that's the
But the picture I get, my God, it's going to take a long time. Okay. At the same time, as you just mentioned, and I know that if instead of, we've got timber doors, because this was done in 1970, by the way, or something. This was when this building was built. If I decide that I'm not going to use aluminium, but I'm going to go for teak wood, or good seasoned timber, which is properly engineered, I know that I'm going in the right direction. I don't have to exactly find the numbers, but I know I'm definitely going the right direction. We have enough information on embodied energy of materials to know that a good timber window will be
Right.
1/100 of the embodied energy of an equivalent aluminium window. Right? I know that.
Yes.
I know, for instance, that if I build a 4-story high building, which is earthquake safe, I can design it with 25 kilograms of steel. I don't know how to count. 25 kilograms of steel per square meter. I can design it at 25 kilograms of steel per square meter if I'm doing a 4-story high building. Whereas I know that if I go to a 15-story high building, I'm talking about 60 kilograms of steel per square meter. So I know that to do 4-story is less steel intensive. Right? I know that CSCB, stabilized earth block, is less embodied energy, much less than burnt brick. And we now know, it's been proven, that it is a perfectly safe material to use. You just have to get into production. So without waiting for standards, I think with this common sense knowledge, there's a possibility of shift in cultures and acceptance of alternative materials and a drive towards low intensity of cement and steel in design itself without having standards. Yeah. Now, you want to add something?
No, I totally agree with you on that perspective that it is possible without the standard.
Speak up.
Yeah, and the other observation is that what I feel is the design team is something which can actually drive this low carbon stuff, because the corporates, the client actually believes, and I have seen buildings, I have seen designers, I have worked with designers who were able to convince the client to add shading, and just take an example, to add shading elements. Those shading elements were actually not serving any purpose in terms of shading it, these were aesthetically. And I have seen designers who have actually convinced the client that there are issues with shading elements, so please remove it, even if it is something which is actually shading the building. So somehow I also feel that this design team is something who can actually push innovation, low carbon design, if they want to, or there are other factors of time and other reputation that what if we try this new material and if it does not work. So that is something is are there. But I really feel the design team, the structure consultant, the architect, the plumbing, the electrical, if they really look into innovation in their subject, it can really, any client can implement those things. So in terms of CSB or any innovative technologies.
So I guess the question sort of is that if we know we're going in the right direction, why can't we just make the change happen? We can, but that will sort of come at the level of intuition or belief, rough numbers, and it will come with it won't come with the kind of confidence that somebody has when they can hang their hat on a number, right? And what we're talking about here is market transformation. So embodied carbon is not something that is it has nothing to do with the return on investment for the developer. It has nothing to do with the occupant. It has to do with a societal benefit that people have to see. Therefore, you need to transform the market with policy. And policy is going to come in three forms, which is either sticks like mandatory codes, or carrots in the form of incentives, or recognition in the form of rating systems. And all three of them, whether it's carrots or sticks, will require the numbers where policymakers can hang their hat on. So if we don't have the real numbers, and if we are not able to have the product declarations and the numbers with them, I think to make this become accessible to everybody, where there's a confidence in the market about what we're doing and that shared information, without that we won't be able to get there.
Yeah, of course, that's a very valid point. So now I just want to come back to Mr. Mehti, Dr. Mehti, about, there's a lot of concern sometimes about how employment patterns in the building industry might change, and whether with mechanization and automation and so on, and switch over to certain materials, there might be loss of jobs. Is that a real fear, in your opinion, in the production of, let's say, block work for walling systems or for cement and steel? Do you think that's a real fear at all? Given that we're going to require much more building construction materials in any case.
That's what I come into. 20 years ago, or even, there was a great fear in the government, state governments, especially the government of Bihar, government of West Bengal, Odisha, that if I introduce computer systems, then the jobs is going to vanish. Has that happened? Jobs has increased. Employment has increased. What I feel is that employment will increase, but the quality of employment is going to be much more high. And there I relate to Prasad's initiative also, where you need to train much more people. So there will be, automation will be for, unskilled jobs might go down, but skilled jobs will go up, because there will be increased demands. If the cement demands increases, if your construction demand increases, you will need qualified architects, you will need qualified engineers, you will need qualified construction companies. So the quality of jobs are going to increase.
So I think we are probably now coming to the end of our session. So I'm just going to ask each one, starting with you, Somit. What would be, say, your recommendation for policy from AEEE, because we are representing AEEE platform right now? What would be your recommendation, one or two, that you would like to put forward?
Sir, two recommendations. Number one is, as all the speakers also said, that we need datas. We need datas, we need evidences to influence the government. So evidences, datas is one of the areas where we need to work through well-defined reports, well-documented reports with datas. It is not with, and you said that we need baseline datas also. With datas, it cannot be simply qualitative, it has to be quantitative. Number one, and that is the area I think we can work all together. The second thing is that finalize policies of, I heard the word, it's one of my favorite carrot and stick approach, the carrots of incentivizing the adoption. So the policies towards incentivizing these. And one thing which I noted from you was very, very interesting, which is in your building products, as you now declare that you have this amount of sodium, this amount of fat, this amount of carbohydrate, why can't you declare your embodied energy or embodied carbon into your products? If it can be made it.
So now, Anish, your recommendation.
Sure. I agree completely, sir, with the points you mentioned. Maybe just adding one thought to that about the procurement piece again. So really, as the biggest probably influencer of construction projects being developed in India, the government and its various departments, through that, can we get specifications, can we get procurement targets for low carbon materials, for low carbon cement, not just at maybe the broad level, but also at the very project specific level. We've heard from some cement companies that even blended cements are not allowed to be used in some infrastructure projects still. We're still using this old specifications of OPC. So that kind of change in the specifications in the procurement policies, that really would give that signal to the entire value chain that yes, there is demand and need for going towards low carbon materials.
Okay, three things. Can you hear me? Yeah. So three things. One is, we talked about this from the supply side. Let's talk about it from the demand side. Homes, especially homes, because 80% of the construction is going to be homes and residential, should be labeled for their embodied carbon content. Whole home embodied carbon content. And if you get to net zero, great. If not, that's okay, but you label it so that we know that when you buy a home, how much carbon has got into it. Second, if you're going to be a registered architect or a registered civil engineer, you bloody well should know what embodied carbon calculations are and how to reduce it. And third, that national education policy alignment of the Council of Architecture needs to be revised so that we have this enabled within the workforce.
You have the last word.
Yeah, so I think what I have observed is disclosure. So with this ESG thing coming in, I have actually seen, since the organization has to disclose they're already doing their financial numbers. Now with ESG, they are disclosing their environment, social and governance. So if on this carbon number, if it is made mandatory that every building has to disclose their numbers to the outside public, because right now even if it is label has that information, but if you are talking about any certification, in the end what is disclosed to the outside public is gold, silver, platinum. You don't get into the detail which credit they attempted, what was their rating in those credits. So this disclosure, when it comes out, then as I said that, if manufacturers are doing disclosing their EPDs, they will also now becoming sensitive to those numbers. So as the buildings are making it disclosed to the outside world, they will start looking into this number because that will be compared among their peers. So something on disclosure, like either a part of BRSR or something where these are disclosed to the outside public and outside public have access to that number. So I think that will make a change. Again, just was thinking, like the transformation that was made in this lighting industry by LED, that was bulk procurement. I am not sure what is stopping, because I believe the biggest contractor in this country is the government, CPWD. Right, so if there is a huge demand and if similar kind of transformation can be done, which we have seen in the lighting industries switching to LEDs, I'm not sure what is stopping, for moving to a low carbon cement and creating that demand and bringing the, technology or the cost down. So.
Well, thank you for your recommendations, and I think we'll pen down these recommendations and hand them over to AEEE. I don't know whether we have any time. Yeah. A couple of questions. Please tell us who you are and who you are addressing your question to.
Thank you so much. I am an architect, and I am an aware architect. I know embodied carbon. And Ashok sir was a jury in third year. I am a graduate of SP Delhi. I work at World Resources Institute. My question is to everyone. When we started this discussion, we discussed that XYZ percentage of build, there's so much construction that is going to happen in the next 3 decades. And my question is that so much of construction which is underutilized and is lying vacant. We are not documenting that because I know we have just started documenting it, and we have around 11 million vacant houses in India, out of which 20% is in Maharashtra alone. So what are the policy instruments, or what is on the policy side that we are thinking to bridge this supply and demand gap? Because lot of the structures which are now coming up, especially in the housing sector, because the state is no more the provider of housing as it was initially when India became independent. So this is a PPP model, and there are private players. We are supplying a lot of high income group and middle income group housing, but the demand is not there. The demand is in the lower economic group. So then we have slums, then we demolish them, and we say that uncivilized folks, all those things.
So can you come to your specific question?
So my question is, what on the policy side, and how are we trying to bring it into this discussion of demand and supply gap? Because we are looking at demand and supply from some other perspective, and I'm looking at
Okay, so if I may reinterpret your question a little bit. One point is that there is already excess supply in some zones, and that we should be talking about utilizing that before we talk about new construction. Second is that when we're talking about new construction, we better make sure that it is for the right market where the real demand exists, and not for other markets where it's only speculation. So you need policy instruments to make sure that the investment in new construction is where it is actually needed, it's best utilized. Yeah, so we accept your position, and we will make that a recommendation, sure. Yeah. Any other question?
Hi, Daniel with Energy Solutions. What is the cost differential right now between low embodied carbon, cement, and I guess the base product? What is the cost difference right now as today between low carbon cement and the base product?
Yeah, there is a misconception that if it is of low carbon, then it will be costly. In low carbon cements, compared to the normal cements available in the market, in Indian context, it is 20% cheaper. In African context, it is roughly ranges between 35 to 40% cheaper. To produce, calculating all the cost, taking into account all the costs. That's the kind of profitability. Now, whether that profitability will be passed on to the customer or not, that I am not a cement manufacturer, I cannot say. But that's the kind of profitability.
Yes, sir. I just wanted, I think we should keep in mind that not all problems can be solved by policies as well. And I think that's a very, very important point on this issue, that if there are vacant homes, maybe there is an Airbnb solution there, that if people can actually utilize and increase the utilization. Developers are going to chase money. Developers, you cannot policy set and say that, hey, you have to go and build, I think, for low-income society. Then I think the government public investment has to go into that to actually cover for that. You cannot ask the private capital to actually subsidize the problems that we are facing in the society. And that's why we feel that there are problems that we can solve through policies, and there are some problems that I think you cannot, or you have to incentivize, I think, if you have to. Just my point.
Thank you so much, sir, for that. I have been thinking about this for a while, and I've been reading about it for a while. I think I was not trying to say that it's the developer's moral responsibility to, bring some change. I know that there is a affordable rental housing scheme that the government has come up with, and they're trying to see, what can be done together. Like, I'm not trying to give this on the shoulder of the builder, ki now you do it. But we have to also understand how did we reach here? Because if I'm building 100 homes, and after filling 50 homes, my profitability is met, then if I'm becoming unconcerned about the rest of the 50, it means that there's some problem. And obviously, every builder would want to fill those 50 homes. So that's why it's a larger, very complicated issue.
Okay, I think on the broad issue of policy, we do understand that policy cannot solve everything, but just by having the right policy, you're not going to get the right results. But I think we're talking about low embodied carbon principally, and we're going to focus ourselves on that. Last comment.
Hi everyone, I'm Anushma. I work as a green value partner at IFL Home Loans. My question is regarding the low carbon materials that we discussed. Is there any directory of these materials with the vendor details? Because a lot of the times when we suggest those materials to the developers, they ask us about those things. And we have observed, since a lot of the manufacturers or vendors are not, basically into all these low carbon materials, and we don't have many vendors in NCR region or in specific regions. So that's the main reason the developers are also not able to use them. So have we any such directory of those materials? And also, is there any linkage of these materials with the carbon credit system or the market? Or are we thinking about something? Because
I think your question was addressed earlier, that there isn't a, you need disclosures for the production of each material. This will happen through formal systems where there's a method of calculation and disclosure, which is then checked by an authority who certifies the disclosure, right? So it's going to take time. But I was only talking about a comparative method, saying that this would be better than that simply because it is a less carbon intensive material. But I think we'll have to wait for that to happen. But at the same time, even while the developers are trying to make choices, if they've got 5 materials lying in front of them, we do know which one is the most carbon intensive and which one is the least. Okay? We do know that much. Right, I think we have now run out of time without any further. I won't try to summarize. I think we've got a lot of wisdom and from everybody, from their experience and their knowledge. Thank you all very much. Thank you, the audience.
I thank our panelists and chair for their invaluable insights. Now I invite Dr. Bhaskar Natarajan, Director of Programs from EEE, to present a token of our appreciation to all the panelists and the chair.
This one low carbon stuff. Yes, sir. Yes, sir. Thank you. What is the carbon of one photograph? Thank you, sir. Yes, sir. Thank you.
I'll also request the audience to move to the banquet hall, where the session on scaling of financing for energy efficient projects using independent measurement and verification powered by Eurovent is going to start shortly.